Hello guys, good evening. How are you doing all? So how's the studies? Uh, we thank God, Alhamdulillah. So here is a little stuff for you guys under EE E311, which is the first example given to us. The relationship between the diffusion constant and the mobility, which is D and E. Before we move to our example, so let's look at some certain formulas and terms. Here we're having E. Let me use this. Here we are having E, which is the charge, and it's given as 1.60 exponential minus 19, and this is K, which is the Boltzmann constant. It's 1.38 exponential minus 23. So this is the diffusion constant, and this is our mobility of either electrons or a hole. So these are formula. This formula is indicating the mobility of electron, and these are formulas indicating the mobility of hole, whereas this one is diffusion constant of electron and diffusion constant of hole. So if you're given a formula, a question, maybe for example that says calculate the diffusion constant for electron and holes at 300 Kelvin silicon if our mobility of electron is equal to 0.15 meter square Vs and mobility of hole is equal to 0.05 meter square Vs. So what we are first to do is remove out our data. So it's very important in any calculation to get the data first, because it will really help in terms of making the computation and substitution of the values to their respective variables. So this our temperature here is 300 Kelvin, and our mobility of electron is 0.15 meter square Vs, and my mobility of hole is 0.05 meter square Vs, and my diffusion constant of electron and hole is what I'm looking for, so the question mark. So here's the formula. It says diffusion of electron is given as mu EKT all over E, this formula. So just make all necessary substitution. My mu E here is 0.15 multiplied by K, which is constant, Boltzmann constant. I gave the real value at top of this, which is this, and my E is this. So take note of it. I might not move back there again. So all over E, which is a charge. Elaborating it is 0.15 by 1.38 exponential minus 23 by 300, which is the temperature, divided by 1.602 by exponential minus 9, which is the charge. So if you punch everything here correctly inside a calculator, you'll find out that the final answer is 3.88 exponential minus 3, which is it is in millimeter square per second. So these are our diffusion constant for electron, and our diffusion constant for hole is given as UHKT over E, which is equal to 0.05 by K by 300 all over E. These are Boltzmann constant, these are our E. They are constant. You can find them in your calculator also. I didn't mean I have a calculator. I could have shown you how to get these constants. So it will be equal to 0.05 by 1.38 exponential minus 23, which is my K constant, by 300 whole over 1.60 exponential minus 19, which is my E. If you punch everything here correctly in your calculator, just try it please. It will give you 1.29 exponential minus 3 meters square per second. This exponential minus 3 is indicating milli, so millimeter square per second. So hope you understand please. If any tough places encountered, please let me know. So thank you so much.